Hello, can you hear me?
Yes, madam.
Yes. Just give me a minute.
Good morning, ma'am.
Good morning. Just 1 minute.
Good morning, madam. Good.
Sure, ma'am.
I'm ready.
Okay.
Madam, can I start?
We start?
Yes,
Yes,
please.
yes, sure.
Okay, sir. Okay. A very good morning to dear participants.
Good morning, madam.
Good morning, sir. So, welcome everyone once again to this ICACIS. So, this conference is going to provide an opportunity to all the practicing engineers, academicians, and researchers to meet in the forum to discuss various issues and its future directions of various emerging technology of allied areas of industry applications. So the basic aim of this conference is to put together the experts from relevant areas, and they'll be coming forward to disseminate their knowledge and experience for the relevant future research scope. And the conference has publications sponsored by CCIS Springer Nature. So starting with the first session of the day, we have with us just a second. Okay, so starting with the first keynote of the day, we have with us Professor Celia Shehnaz, Professor, Department of EEE BUET. So the topic for today's keynote session is going to be on 2D biosignal processing for automation in disease detection based on deep neural networks. So just a brief profile about Professor Celia Shehnaz. She's SMI EEE Fellow IEB, and she received a PhD degree from Concordia University, Canada, and currently a professor at Department of EEE BUET, Bangladesh since 2015. She was the winner of Canadian Common Scholarship for pursuing her PhD studies in Canada and recipient of Bangladesh Academy of Science Gold Medal for her contributions in science and technology. The World Academy of Science members have elected her as a fellow of TWAS for advancements of science in developing countries effectively from 1st January 2023. Recently, her nomination has been approved and she has been inducted into IEEE ETA Kapanu as a professional member into the ETA chapter of the Board of Governors. She has been elected as 2022 IEEE Women in Engineering Committee Chair-elect, and she's serving as the 2023-2024 IEEE WIE Committee Chair. She has been appointed as 2022-2023 member IEEE New Initiative Committee, member IEEE History Committee, and many such IEEE portfolios are added as a feather to her cap. She is the recipient of 2021 IEEE MG Achievement Award, 2021 Inspiring Women in Academia Award from Bangladesh Brand Forum, and Art and Humanitarian Activities Outstanding Volunteer Award, 2016 MGA Leadership Award 2015 Women in Engineering Inspiring Member Award and 2013 R10 WIE Professional Volunteer Award. Ma'am, basically, I look up to you as my personal mentor. And you know, you are definitely a great inspiring women leader in the technical forum. So without any further delay, I now request you to kindly enlighten all the young minds present here and kindly direct us regarding the technical topic that you have been confirmed to deliver. So I request you, ma'am, to kindly start your first technical session.
Thank you very much. Thank you for the humble introduction. Hope I am audible to every one of you.
Yes, ma'am, you're audible.
Yes, actually, I'm at the United States having some board meeting, but I could not say no to Ankush. Ankush, thank you for the invitation. This is a very great opportunity to connect with you all. It's an honor. And I'm really happy that you are organizing conferences to disseminate information and share ideas and connect the speakers with the young generation. So let me share my screen very quickly. Let's see. Yes. Hope you can see my screen, right?
Yes, ma'am. We can see the
Okay.
screen.
Okay. I'm so happy that somebody has created this poster, that silent hero. Please say my regards to him or her. This is very important, who has created it and which you have been using it for dissemination and attracting speakers. This is just my brief bio. I request every one of you to visit my website, www.celiashanas.com, to know about me. Okay. And as said, that I have been a research for more than 22 years. I'm founder of 4 Technical Society chapter and like Industrial Application Society, Society on Social Implications on Technology, Robotics and Automation Society, Signal Processing Society. And I also request everyone to visit my Google Scholar profile to understand that despite many limitations, how my students are working very hard to publish impactful journals and conferences. This is an inspiration for the people who are living in this part of the world. That means in the subcontinent, okay? For your kind information, I have been elected as the Global Women in Engineering Chair for the first time in the history, a chair elected by the global members of IEEE. This is a great honor and a great opportunity to bring benefits to all of you. WA is not just for women. Any male and female can be part of it. It is diversity and inclusion. For your kind information, IEEE has a world-class magazine. They have published my interview in June 2020 issue, also June 2023 issue. They have published my plan as a Women in Engineering Chair, where research and innovation is playing a very important role in my vision as a Women in Engineering Chair. The first topic is actually the abnormality detection from musculoskeletal radiographs. And for that, my students have developed a capsule network. Okay, because 1.7 billion people are suffering from these diseases. And this has been published in IEEE Access. This is just a block diagram. And for this work, we need pre-processing. And if you see that there are different pixels and we are increasing pixels size, and we didn't depend on the subjective evaluation only. We depend on the training accuracy, validation accuracy. We can see for 2 to 4 cross 2 to 4, both training and validation accuracy are higher. We also evaluated BRIC score and NIC score, and for 2 to 4 and 2 to 4, both the scores are lower. That means we lose less information after resizing. This is just a proposed structure because it is, and for convolutional one, then convolutional capsule layer, then the class capsule layer. So if you see it, then you can see the flow. And before going to the decision of normal and abnormal, we do routing by agreement algorithm. This is very, very important. If you go to my paper in the Google Scholar profile, you got these equations, and that will help to realize more. But for any data in the communication, transportation, and intelligence system, it is important to know what type of data you're using. We are using publicly available MORA data set with more than 14,000 images, and more than 18,000 images are normal and more than 5,000 images are abnormal. So we don't have data imbalance. If data imbalance were here, where we needed to do the data augmentation, okay? And this is the effect of routing by algorithm. If we increase the routing number, then accuracy increases. But for some cases, you can see the last but one row, we can see the overfitting occurs. To avoid overfitting, we decided to take 4 routing. So we have also evaluated ourselves with the Cohen-Kappa statistical score. We have plotted and comparison for different radiograph images with conventional DenseNet, which is blue color. We can see the proposed CapsNet in green color having 10% better accuracy with 50% less training data. This is very, very important. And we have compared our result. Our comparison metric is training accuracy and testing accuracy. We have also evaluated with a standard method, and you can see that our proposed CapsNet are providing higher training and testing accuracy. Now you can question how appropriate and how accurate your model is. So we have plotted loss accuracy curve, and we can see red color, we have high accuracy with low loss in the black compared to the conventional DenseNet, okay? And let's discuss another topic. You know, we want to detect tuberculosis from the chest radiograph, exploiting the cascaded ensemble of features, okay? And this is the cascaded ensemble. Lower row, you can see a couple of deep knurling architecture like DenseNet, ResNet 50, Inception V3. In the top layer, we can see some handcrafted features. Then we actually do the ensemble of deep knurling architecture and the other handcrafted feature to reach a better decision. You know, these are handcrafted feature, and we can see individual handcrafted feature quality is less than the ensemble feature quality, and it has been shown by Bhattacharya distance, BC, and geometric separability index, okay? And here is the result. For result, we have evaluated with more data set like MC and Sanjan data set, and there are different evaluation matrices like accuracy, area under the curve, sensitivity, specificity, okay? Now, before going to the deep neural network, we need to know which layer provides the better accuracy. We have analyzed Inception V3, DesNet 169, and ResNet 50. By bold, we have shown that which layer is providing the better performance evaluation matrices, okay? And after this, we have also shown that with augmentation, the evaluation matrices are higher for both the database if we can do the deep neural network ensemble, okay? And after deep neural network features are assembled, they are sent or fed to the logistic regression, SVM, NNK, and random decision forest. And from here, we came to know that Logistic regression is a better classifier compared to the others. Now it is time for comparison with all the available techniques in the literature compared to all our handcrafted feature and deep neural network. This combination for 2 data sets for tenfold validation, our results are higher coming, performance is coming. Now we had a great CRAM evaluation. We can see the first row is a normal and second row is a tuberculosis, and there is a remarkable difference in it. And we don't want to observe using such a great CAM. We want to automate the process. That's why this algorithm, if it is given to the PC of the doctor, it can provide data, and from doctor's chambers, data can be sent to the user. It is very, very important to automate the process. Another important, my favorite research is COVID detection from different imaging techniques, and our students were so much excited. They were able to make a difference between COVID, pneumonia, and normal. Apart from just saying it is COVID or pneumonia. And this is CapsCovNet. This is the picture of CapsCovNet. We do the slicing, and then we have a parallel convolutional block. We have a concatenated capsule block. Then we go to decoder block, and after going to the decoder block, we got the decision. Okay, and these are parallel convolutional neural block with different sizes. And this is concatenated capsule network with different sizes. This is a decoder network. It is very important to understand it to get the decision. We can have a reconstructed image at the same time. We can have 3-class classification. So for this, we did 3 databases with evaluation matrices. So we can find that with pre-training, with enclash pre-processing, the results are coming good. And most important here, I show the capsule network with parallelly connected convolutional block, which is providing better result compared to the capsule network with sequential or convolutional block. Okay. Now it is time to compare the method with all the rest of the papers. We are really outperforming them, and later on we can show comparison of our paper with other 2 papers in classification of COVID, pneumonia, and normal. And we are also outperforming here. Here is the CRAM visualization, and we don't want to visualize it also, although it is very easy. We want to hand over this CRAM visualization to the doctor. Rather than telling it to the doctor, we do this automatic and finding the problem. Okay, this is another work my students have been doing competition in 2020. ICIP, distortion classification laparoscopic videos using DisNet network. This is input image. We identify the 4 types of noises, then extracted the feature array. Once the feature array is there, then we can really have it. So this is a white Gaussian noise, and this is a smoke level detection. This is uneven illumination. This is blur test estimation, like that. Okay, so once we estimate, then we get the input. Then we parallel serial COVID blocks, sequential self-attention before going to the LSTM. LSTM goes to dense goes to other batch normalization. Okay, and this is the model performance. The model accuracy is high compared to the lower loss. Okay, and this is model performance, accuracy and loss. Accuracy is high and loss is low. Cohen-Kappa statistical score is also commendable position to evaluate the performance in unseen data. Unseen data, we have separated. Unseen data, we have separated a portion of the data set besides the training and validation. And we can see the average accuracy in Cohen-Kappa score did not increase much. So this is the comparison with our, and for compared to the all, our method is doing better accuracy, but with a very less time. And this is another important thing, that we are a strong advocate of women, not only in my delivery, but it is important to promote research which are related to women and children. This is skin cancer detection classification. These are the images with skin cancer. These are some awards from the regional level, global level, MGA leadership level, humanitarian technology level. MGA achievement award is a great opportunity to serve you. It will be great if you can apply some of this award. And these are our group awards. This is our society award. This signifies the importance of doing society, which is important. Sound signal processing, only $1 for the graduate student. So we can change the world because we are engineers. This is the link of my website. Feel free to contact me for any future engagement. I'll be happy to provide support to you. Thank you very much. If you have any question, you can ask.
Thank you so much, ma'am, for a wonderful insight. I request the audience and the participants, if you have any questions, we can come up with few questions.
Yeah.
Any participants can type their questions in the chat box.
So this is a tool actually. If you can learn the tool, you can employ it anywhere. Biomedical signal, speech, image, video, power signal, robotics related to signal, industrial automation, everywhere you can apply. So you need to know the deep learning tools, Python and those things, so that you became an effective part of the research community. Thank you.
Ma'am, one question I have from my side, since I also have been working in this deep learning neural networks. So one problem that, most of the researchers face is the hardware issue, right? Because, when we are training a large amount of video or an image, we need to have physical GPUs. Otherwise, we have to use these cloud-based GPUs. So, as a researcher, many a times it gets very difficult to afford these GPUs, right? Because the rented, many times we just forget to close the virtual sessions and, it keeps running on the background. So can we have a common solution to it? I mean, what can be a solution to this?
You can use the Google Colab.
Okay.
Google Colab they will have some free space. Or I have a student, he runs different competitions. He becomes winner. Then Google gives him the free place.
Right.
So of opinion. When I had nothing, then I inspired him to use the Google Colab account. Then after when the more competition, then I have paid or I have supported to do the pro version, or keep on winning the competition to get the proper size. So we have to find avenues. I have just shared how I find avenues for my students. Also, we have an Institute of Information Technology. They have GPU support, and I have requested GPU support by applying to them through an application. That GPU support is already there. So these are the way we have to find avenues. Since we do not have much resources, we cannot stop our work. We have to find the avenues. Thank you very much.
Yes, ma'am. So thank you, ma'am, once again for this wonderful insight towards, biomedical and healthcare application using deep learning. I'm sure every participants are enlightened by your research, and we have gained a lot of knowledge which we will be applying in the near future for our own research papers and articles. Thank you so much. It was a wonderful session. So I request once again from the audience, if you have any questions, we can put up, or we can, any questions from the audience? Okay, ma'am, I think the audience are very, very satisfied. And like any one of you have questions, we will be definitely personally communicating with you. And we are sure that you will be always ready to help us and solve our queries. So thank you, ma'am. Thank you so much for giving this wonderful insight. And it's an honor
Thank you very much.
you with us on this international conference on advanced communication and intelligence systems, which is powered by Stringer. Once again, thank you.
Thank you very much. Take care. For any problem, for anything, just reach out to me. I'll be there to support you. Thank you very
Sure.
much.
Thank you. Thank you, madam.
Thank you, Ankush. And thank you, Rabindranath, and thank you, our moderator. You did an excellent moderation, and I tried my level best. Thank you.
Thank you.
Take care. May I leave?
Yes, ma'am.
Okay.
Okay. Wish you all the best for your conference. Okay. And in future, much before the conference, please discuss with me so that I can offer more help. Okay.
Sure.
Thank you
Thank you.
very much. Take care. Take care. Bye.
Thank you, ma'am. So dear participants, now the technical session will start at 10 a.m. So I request all the participants to come back at 10 a.m. and join us for the first technical session, which will be on the first track, communication and networks. So the next session will start at 10 a.m.
Okay, madam.
Thank you.
Thank you, madam.
Good morning, sir. Shall we start the technical session?
Yes, please start, madam.
Okay, sir.
Madam, my screen is not appearing properly. I don't know what's the problem.
Okay, sir. We will check. Yes, sir. Now your screen is visible.
Okay, now my screen is appearing.
Yes, sir. Yes. So, good morning, everyone.
Good morning, madam.
Yeah, good morning. I, Dr. Garima Shukla, and I, with my fellow Parithro, are going to host this session. It is my great pleasure to welcome you to the International Conference on Advanced Communication and Intelligence System, ICACIS. I take this opportunity to welcome our session chair, Dr. Sunil Kumar Singh and Dr. and all the authors for this session TS1 to TS4. ICACIS will provide an opportunity to the practitioners, engineers, academicians, and researchers to meet in a forum to discuss various issues and its future directions of various emerging technologies of allied area of industry applications. The conference aims to put together two experts from the relevant areas to discriminate their knowledge and experience for the relevant future research scope. The conference has publication sponsored by CCIS Springer Nature. It gives me immense pleasure to introduce our session chair. First, Dr. Sunil Kumar Singh. Sir is working as an assistant professor in a Department of Computer Science and Information Technology, Mahatma Gandhi Central University, Bihar. He has 8 years of experience of teaching experience and research experience. Earlier, he has serving at Galgotia University, Greater Noida. He received his MTech and PhD degree in a computer science and technology in a year of 2012 and 2017 respectively from the School of Computer Science and System Science from the Jawaharlal Nehru University, New Delhi. Dr. Singh has published around 17 research articles in various international journals and conferences. His research interest is in the area of machine learning, mobile computing, parallel computing, Internet of Things, and blockchain technology. Now, our second session chair, Dr. Arun Kumar, sir, did his PhD and MTech from computer science from Jawaharlal Nehru University, New Delhi, BTech in computer science and engineering from UP Technical University, Lucknow. Presently, he is working as assistant professor, Center for Excellence Studies, Dr. APJ Abdul Kalam Technical University, Lucknow. Before joining CAS, he was working as associate professor at Galgotia University till 2017. He has published more than 30 research papers in various reputed journals and conferences and guided many MTech projects too. His research of expertise including mobile ad hoc network, multimedia communication. So welcome both of our session chair in our today's conference. Now with this introduction of our session chair, I am announcing the paper IDs and their title which are going to be present in this session. I would request all the authors to make your presence in the chat box once I call your paper. So with the permission of our session chair, sir, shall I start the sharing of the presentation?
Yes, ma'am, you can start.
Okay, thank you, sir. Parithro, sir, please start the first presentation.
Yes, first presentation. Hello,
Ah.
I am audible.
Yes, sir, you are audible.
Parithro,
Actually,
could you share the paper ID, paper title, and author name for this session?
Yes, sir.
Very much.
First paper ID 2401. Cloud computing enable autonomous forest fire surveillance system using Internet of Things. Presented by Kaushal Mehta. I will share 2401 paper ID.
Yes, sir, I am available. Yes, sir.
Very good morning. Very good morning. Myself Kaushal Mehta, and I am here to present my paper in International Conference of Advanced Communication Intelligence System. My paper title is Cloud Computing Enabled Autonomous Forest Fire Surveillance System using Internet of Things. My paper ID is 78. The contents that I am going to cover is introduction, literature review, proposed methodology, advantages, challenges, future perspectives, conclusion, and then references. As we are familiar with that Global Forest Resource Assessment, they released the report about what is the status of the forest globally. So they found that the area covered by forest is 4.06 billion hectares, which is approximate 31% of total land as per the report which is generated in the year 2020. It is the home of various species of flora and fauna. Even humans are dependent on the forest for fresh oxygens, food, to balance the environment. This graph represents the acres of land damaged in last few years due to forest fire through the world. As we see that 31% of the total land covered by the forest, and it is continuously decreasing because of the forest fire. So this graph represents the number of fires taken place in the forest globally, and we can also see in last few years the number of fires graph is somehow affecting the total land covered by the forest. There are a lot of work have been done to detect the forest fire. There are authors who made IoT devices using GSM module, GPS module, and ESP32 module, and they placed those sensors in the forest to detect the forest fire, and they aware the concerned authority through SMS. And there is one drawback that this author identified, that SIM card is required. So somehow the network connectivity is something that this IoT devices has limitation. Another author also discussed the emerging technology using IoT with image processing, and that processing of data is done using MATLAB software, and the alert is generated and nearby water pump get triggered and spread out water in the case of fire. So this is the proposed methodology where we have used Node MCU, which is microcontroller and Wi-Fi enabled, and we have deployed two sensors. One is flame sensor and another one is gas sensor, and through Node MCU, whatever data is generated and collected by the sensor, it is transferred to the cloud storage, and the monitoring station in real time can access that data and make the necessary arrangement if required. So in the result, as you can see that on the website portal, through both sensors, gas sensors and flame sensors, they are showing real-time changes in the case of fire or smoke detected. There is another picture where the detection through both sensors, gas sensors and flame sensors, can be identified. This figure represents the real-time data collected through Firebase. This is the hardware setup which was done to collect the real-time data for the forest fire. This is the advantage of the proposed model: scalability, improved accuracy to detect the forest fire, easy access of data in real time through the sensors and the cloud, and the predictive analytics that makes easy to the observer to detect and identify that how much area would be affected if the forest fire or smoke is detected, and what is the rate to increase the forest fire. And the cost effectiveness is there, and the real-time monitoring is also one of the advantages. There are few challenges of the proposed system: data privacy and security, interoperability, cost, maintenance and upgrades, technical expertise, and the network connectivity. There are few observations that can be helpful in the future. The proposed model have improved data analytics, integration with new generation technologies, increased adoptions, wider deployment, and the advancement in IoT devices. So these are the future perspectives of the proposed model. In the conclusion, we see the modern technologies working round the clock to find the solution and solve the real world issues like forest fire. In terms of cost and uses of the resources, it is very important it should work in sync and should work well. And we also try to resolve this problem using the technology. And the work that we have done, we have tested the environment and try to provide the solution using Internet of Things and cloud technologies. So in this slide, we have talked about the references. So these are the references. Thank you so much.
Now I'm request to our respected session chair, Dr. Sunil Kumar Singh sir and Dr. Arun Kumar sir, to give to ask the question to the author. Sir, please.
Yes, sir.
Which protocol, IoT communication protocol used for in your setup?
This is Node MCU we have used for setup. Node MCU and two sensors we have used. MC
No, for the
Q20.
communication protocols. For the
We are using cloud computing and fire-based system.
data transfer, for the data transfer from one node to the another node, there are some communication protocols used to transferring, which govern the transmission of data from one node to another node. Then which protocol?
So that data is transferred from this Node MCU to this cloud
Okay, then
Firebase online.
okay.
This is real-time system and Wi-Fi is used.
No. And which communication protocol is used for the communication?
Communication protocol.
Can you define the protocol? What is protocol?
Yes, well, that is the rule for communicating the things.
So when we are going to use two devices and if they are going to communicate, then there are some, predefined protocols. And of course, when you are going to receive the data in terms of, let's from some sensor to some device, so it follows a protocol. And I think Arun sir is talking about which protocol you have used to receive this data.
So that
there is a hint, a lightweight protocol, often used for the receiving the data from sensors to the device. So if you have any idea, you can explain in that terms.
Yes, sir. Lightweight protocol we have used for transferring the data.
I think you have not explored the protocol. Just
yes, sir.
Okay. Anyway, Arun sir, please.
Okay, no, Sunil, you can carry on. And
okay, so it seems like your work is quite interesting, and can you tell us what is the use of cloud? When you are going to having the surveillance over the forest fire.
Yes, sir. Cloud, we are transferring data and we are using Wi-Fi technology, and cloud is used for using real-time data. Whenever the forest fire takes place, so that
Which cloud you have used? Which cloud you have used?
Firebase. So
Okay.
Firebase we have used.
And by using your Node MCU.
Yes, Node MCU and two sensors.
Which platform? I mean, which programming languages you have used to
Rect.js. Rect.js I have used.
Yes.
So Rect.js I have used. HTML,
Okay.
Rect.js, and CSS I have used for making the website.
No. I am talking about to receive the data from Node MCU. There is a programming, interface is required to receive the information.
Python, sir, I have used.
Okay, fine. Thank you. That's all from my side.
Thank you, sir. Any more questions, sir?
Any question from the audience? Ma'am, after audience, we can go for the next paper.
Yes,
If any
sir.
question
Okay, thank
can
you,
be
sir.
asked.
Thank you, madam.
Thank you so much, sir, for
Thank you.
your wonderful research work presentation. Anyone have any question? So now we are moving to our next presentation. The paper ID is 3637. Ishani Roy. Ishani Roy is present.
Yes, ma'am, I am present.
Your paper title is A Review on Machine Learning Based Security in Edge Computing Environment.
Yes, ma'am. Yes, ma'am.
Okay. Orithro sir, please start the presentation.
Hello everyone, my name is Ishani Roy and I am a MTech student of Maulana Abul Kalam Azad University of Technology, West Bengal. Today, to be a part of International Conference on Advanced Communication and Intelligence Systems, I really feel fortunate. I am going to present a paper entitled A Review on Machine Learning Based Security in Edge Computing Environment. I have divided my entire paper into certain sections, which are Introduction, Edge Computing Architecture, Security Threats in Edge Computing, Literature Survey, Comparative Study, and Findings from the Survey. As this entire paper is based on edge computing domain, first we need to understand a few things about security problems in edge computing environment. The increasing demand for advanced services and applications such as virtual reality, augmented reality, and infrastructure for smart cities has created huge challenges on cloud computing. Edge computing has been proposed as a new computing paradigm where resources like computation and storage are placed closer to the data source. It enables a new class of latency and bandwidth sensitive applications as data can be processed at the nearest edge without sending data to the cloud. However, edge computing also brings new possibilities and challenges for research in the field of security and privacy. Edge nodes are close to the users and as a result can potentially receive large amounts of privacy sensitive data. If the data from an edge node is leaked, the consequences can be serious. Compared with cloud centers, edge nodes have limited resources, so they cannot support complex security mechanisms. Due to the high mobility of the devices and users, the edge computing environment is always changing. Attackers can easily join the group and it is difficult to design security rules with multi-domain overlapping such as device provider, data generator, etc. Now coming to the next slide, I will start from the edge computing architecture. This is basically based on three layers, which is edge device layer, edge server layer, and cloud server layer. Now I will explain each layer with the help of a diagram. I will start from the top layer. The top layer contains public or private cloud. It serves as a repository for workloads that utilize containers such as applications and machine learning models. The software required to coordinate and manage the various edge nodes is also stored and run on these clouds. Workloads at the edge, such as local and device workloads, will be able to communicate with workloads on these clouds. The cloud might be a source or destination for any data that the other nodes require. In the next layer, edge server layer is made of edge server and edge gateways. An edge server is usually a general purpose IT computer that is often placed in remote operations facilities such as company, commercial shops, hotel, distribution center, or banking institutions.
An industrial PC is commonly used to build edge servers. The majority of the time, it is used to operate shared services and business application workloads. An edge server that can serve business application operations and shared services as well as provides network services including protocol translation, termination of networks, tunneling, firewall protection, or establishing wireless connection is generally referred as an edge gateway. Edge gateways are conventionally separated from edge devices, even though some edge devices can perform limited gateway operations or handle network functions. Now in the last layer, edge devices are present. An edge device is a piece of machinery specifically designed for certain tasks and well equipped with built-in processing power. A factory floor assembly line, an ATM, an intelligent camera, or an automobile are examples of edge devices. It is used at EDL to perform various interesting tasks. As example, sensing, actuating, and regulating operations. Typically, an edge device has reduced computing capabilities. Even though the capability of edge devices could increase, they are now the exception rather than the usual standard. In the next slide, from now on, I will start discussing different kinds of security threats in edge computing. First is the DDoS attack. In a DDoS attack, a number of devices serve as attack platforms, greatly enhancing the attacker's ability to launch a successful attack. Due to their diverse firmware, lack of computing resources for security monitoring, and higher percentage of nodes lacking mutual authentication, edge servers are more susceptible to DDoS attacks than cloud servers are. Next, eavesdropping is the unauthorized real-time interception of a private communication, such as a phone call, instant message, video conference. Devices that use radio waves for identification are vulnerable to this kind of attack. As the attacker acquires access to sensitive data like node configuration and identifiers, the confidentiality of system degrades. Now coming to malware attack, it is a common cyber attack where malware, normally known as malicious software, executes unauthorized actions on the victim's system. The malicious software encompasses many specific types of attacks such as ransomware, spyware, command and control, and many more. Now coming to the jamming. Jamming in wireless networks is defined as the disruption of existing wireless communications by decreasing the signal to noise ratio at receiver sites through the transmission of interfering wireless signals. It is a subset of denial of service attacks in which malicious nodes block legitimate communication by causing intentional interference in networks. Now the last, spoofing. In the context of network security, a spoofing attack is a situation in which a person or program successfully identifies as another by falsifying data to gain an illegitimate advantage. In the next slide, I have enlisted two more security threats. One is man-in-the-middle attack. It is a cyber attack where the attacker secretly relays and possibly alters the communications between two parties who believe that they are directly communicating with each other, as the attacker has inserted themselves between the two parties. One example of a MITM attack is active eavesdropping. Next one is phishing. It refers to an attempt to steal sensitive information, typically in the form of usernames, passwords, credit card numbers, bank account information, or other important data in order to utilize or sell the stolen information. By masquerading as a reputable source with an enticing request, an attacker lures in the victim in order to trick them. Now I will start discussing various security models suggested by different researchers. First study explores the potential of machine learning as classification models for defending the IoT from DOS attacks. In order to assess the performance of classifiers, accuracy, sensitivity, specificity, APR, and AUC are the measures that are taken. In the next study, a binary classification model is offered for identifying anomalies as well as a multi-class classification model for different categories of sidebar attacks. The top 10 machine learning classification approaches include SNP-based, stochastic gradient descent, logistic regression, k-nearest neighbors, SVM, etc. In the next study, authors provide a novel intrusion detection technique that creates an RGB image from network data flow that can be identified using cutting-edge deep learning models. A decision tree algorithm is presented to find out the significant characteristics of the datasets. The final step is to classify the generated image using a vision transform classifier. Here, a system is offered whereby assessing the importance of each variable, RF is used to select the best subset of flow features. Then using the selected attributes as input, AdaBoost, a hybrid clustering based ensemble method, would classify traffic into several adapt types. In the next study, the proposed method extracts from the corpus of URL strings a number of very unique and unrelated attributes. Following the collection of these traits, transforming the URL strings into the appropriate numeric feature vectors and then later using them to train a variety of machine learning based classifier models is done. In the next study was done on botnet detection. Here the supervised ML algorithms were support vector machine, random forest, logistic regression and decision tree. Unsupervised ML algorithms deployed were k-means, k-dimensional tree and dbscan.
Now coming to the comparative study. In the first study, XGB performs best in terms of AUC. As a conclusion, XGB works well when training data consists of large number of observations and feature numbers are less than that. In the downside, when there are many input features, ensemble-based classification techniques are vulnerable to overfitting, which leads to generation of poor results in case of new data sample. In the next study, when binary classification is considered, the random forest model produces superior results for detecting cyber abnormalities. It is because of the creation of a set of logical rules based on the chosen security attributes that take into account a number of decision trees generated in the forest and deliver a result based on the popularity of those trees. In the downside, random forest loses a lot of important information while minimizing the features, resulting into poor outcome. Thus, the quantity of features is important in this context.
In this study on the CIC-IDS 2017 dataset, the suggested model had 100% accuracy for both the DDoS attack and Predator attack. In the downside, the most common misclassifications has been found involves misclassification of DOS as benign and vice versa. Because there are very few attack packets at the commencement and termination of a DOS attack, it is easy for them to be misinterpreted for benign packet flows. In the next study, the choice of algorithms for feature selection and traffic classification have an interdependent relationship. Therefore, the authors placed more emphasis on the performance of their combination. In the downside, without prior training, the suggested system lacks the generalization ability to identify different attacks. It proves to be a major setback as this approach cannot automatically detect new types of attack, which is crucial in EC environment. Here, a considerable reduction in features is used. As a result, the suggested framework has significantly reduced processing overhead and model training time than other ones. However, security models that are based on ML are extremely dependent on the quality as well as with the characteristics of the data, which also can produce non-identical outcomes for different datasets. So, feature extraction, fine-tuning datasets play a major role here. In the next one, due to lightweight and quick responsiveness, Random Forest has the ability to provide entirely on-device training at the edge and is easily adaptable to online training. The system is expected to respond or make judgments quickly without sacrificing accuracy. However, in a real-time response scenario, Random Forest delivers great accuracy but with an extended computation duration. From the previous discussion, some conclusions can be drawn regarding the design process of a security system in each computing environment. In majority of the existing methodologies, Random Forest has proven to be an effective classifier, mostly because of its numerous impressive features such as simple to implement and automatic determination of feature importance and interaction. Another notable machine learning method is XGBoost. Extreme gradient boosting works well when training data consists of large number of observations. In addition, less number of features adds to its advantage. These aspects of XGBoost are going to be valuable when the various new types of security threats as well as latency in edge computing is concerned. These are the references of presented security systems. Thank you for listening.
Yes, author can tell which one method you can find best among your yesterday.
Yes, sir. I have done all the research, and I can say that in case of based methods, there are so many machine learning models. They have provided great accuracy and precision. But in my case, I have observed a unique kind of approach, which is basically based on image processing. The whole data set is converted to the image, and then images are segmented, and the new data set of images are created. And on that data set of new image, the extreme gradient boosting, random forest and CNN, convolutional neural network defined machine learning works well.
Okay.
I have observed.
Tell you among those methods, which one have the best time complexity and accuracy?
Yes, sir. In case of time complexity,
Uh,
in case of accuracy, basically said there are certain models like random forest model and
What
extreme
is the
gradient.
value of accuracy in
Sir,
the papers they have collected? What?
yes, in those cases they were mostly in the range of 96 to 97, or sometimes it was 98%. I have got all those. I have observed all those accuracies in all those papers.
And time complexity.
And in case of time, sir, they have not mentioned the time complexity, but they have assured that it was really negligible in case of time complexity and all.
Okay, then Sunil.
Yes, thank you, sir. Anyway, it was nice presentation, Isani. And
sorry, sir, I think my presentation was a bit longer. I'm really sorry for that.
It's okay. It's okay. Actually, I have some set of questions in continuation with the Arun sir, as he was asking about the time complexity. So as we have a kind of conception that machine learning models requires high computation power, and you are saying that the time complexity of random forest and it is almost negligible. So how it is possible?
Sir, in cases of random forest, basically what happens, the whole sample is segmented into certain portions. And
no, Isani, just be straight to the answer. I mean, first define what is time complexity.
Yeah, said the time complexity is defined. There are three time complexity: the worst time complexity, the base time complexity, and the average time complexity.
No, definition of the time complexity. How we define the time complexity?
Sir.
Okay, what is edge computing? Isani,
yes,
what
sir,
is
the edge computing is yes, sir. Edge computing is the or what evaluated version of cloud computing. In cloud computing, what we can say, thus all the data is centered into a central repository. But in case of edge computing, all the edge devices we use, such as mobiles or some other small equipments in our daily lives, the processing power is centered into edge devices. So the whole processing does not need to be done on the central repository. So the network bandwidth is saved, and all the other processing can be done more easily.
That means when processing and storage, comes nearer to the user, so we can say that will be the part of edge computing.
Edge computing, exactly, sir.
Have you heard about mist computing?
No, sir, that I have not heard.
You should explore mist computing.
Yeah, sir, I am definitely acknowledging it. I will work on that.
To complete this review article, how many papers you have studied?
Sir, basically, I have studied other papers also, but in this paper
how many papers I'm asking about, because when we are going to review some area, so we have to explore almost all the papers published in that particular area.
Sorry, sir, that was not possible.
But many times papers are very large in numbers. So what we do, we let's say explore last 10 years papers or last 5 years papers. So that's why I'm asking in terms of how many papers you have explored.
Sir, I have reviewed also almost kind of 20 papers in my case.
How many references are there in your paper?
Sir, it was PPT, so I have cited almost.
In research paper you have published. Anyway, this is your presentation, but your paper will be projected in this conference, published in this conference, right?
Yes, sir.
So how many papers you have cited in your work?
They are almost they are not more papers. Actually, I have cited less papers.
Is it your work or someone else's work?
No, sir, it is my work.
But you are not able to answer. Even it should
no,
be,
sir, I
answered straightforward.
20 to 22 papers I have cited in this case. In my case, it was not it was not that much papers I have said, sir.
Okay, and as Arun sir was asking about the performance of the model, like you have answered in terms of
yes, sir, I have recorded it was 23 papers.
Let me put the question, one more question.
Yeah.
What are the other performance metrics to evaluate the machine learning models?
Sir, it was accuracy, then it was precision, and then, sir, it was F1 score, and there are some recall value. They were the
So
metrics we
what
have
is
used.
precision? Can you define precision?
Yes, sir. Just give me some moments. I will definitely. Sir, basically, precision is the value we can say. Sir, wait a minute.
Okay, Isani, fine.
No,
That's
sir,
all
sir,
from
wait, sir. I'm just telling. It is the basically the measurements is the number of total of true values of observation and to the true values we have got. No, wait, sir,
Actually, it is
wait.
very simple definition of precision and recall. You can explore it.
No,
And
sir.
these are
Just give me some
the
moments.
few observations drawn from your let's say PPT or presentation. That's all from my side. Thank you.
Okay, can we go for the next presentation?
Okay, sir. Now next paper ID is 3763. Ransomware taxonomy and detection technique based on machine learning. Our reviewer author name is Akram Al Bain. Is it present? Paper ID 3763 is present?
Present, ma'am.
Okay.
Hello and welcome everyone. My name is Akram Al-Banna from Sharda University, India. I'm going to present ransomware taxonomy and detection techniques based on machine learning. As the contents of this presentation, malicious software continues to be one of the most dangerous threats in the digital world, despite the significant progress that has been made in computer security systems and the continued expansion of those systems. The term malicious software, which is provided as malware, refers to the harmful piece of code that is written in a malicious manner. Ransomware is one of the most dangerous malware which takes control of a device and prevent the victims from accessing the data till some sort of ransom is paid. They have two options for doing so: local ransomware and crypto ransomware. The life cycle of ransomware consists mostly of 7 parts: creation, camping, infection, command and control, search, encryption, and extortion. The main goal of the creator is to create ransomware using programming language, and camping refers to how the attacker will deliver this ransomware to the victim's machine. During the infection phase, the ransomware is uploaded to the victim's machine and the installation process is started. After the installation process complete, the ransomware will communicate to the command and control in order to collect the encryption key for the encryption process. Next, ransomware will scan the network and search for any and all sensitive data that can be used to blackmail the organization and individual. After the search step, the encryption process will start, and the last step is extortion, that the attacker will inform the victims that his data has been encrypted and he have to pay ransom in order to get the decryption key. The impact of ransomware. Ransomware that encrypts file is risky and costs a lot of money to the society. The European Union Agency for Network and Information Security estimates that individuals paid a total of 10.1 billion euro in ransoms in 2019, which is an increase of 3.3 billion euro over the previous years. The availability of a company's data is an essential component in the overall goal of making the business and accessible as visible. Many businesses immediately opt to incur costs rather than risk losing their data. It's essential to take It's essential to take action against ransomware since it poses a threat to users' data. Ransomware analysis. The goal of ransomware analysis is to obtain a better understanding of how ransomware works and gather new characteristics that may be utilized to bolster security requirements and make escape as tough as possible. Depending on this knowledge, defense measures to avoid any possible infections can be developed. Ransomware analysis Ransomware analysis is divided into static, dynamic, memory, and hybrid analysis. Static analysis examines the portable executable file without running it. A portable executable file needs to be decompressed first using memory dumper tools like object dump or debrasser tool. The detection characteristics utilized in static analysis, including such file headers, byte engrams, strings, OB codes, and control flow graphs, may be retrieved. In dynamic analysis, malicious software is run in a safe environment like sandbox, so that the live activity of harmful files may be seen without the risk of the software causing damage to the system. The API and system calls are used extensively in ransomware runtime analysis, in addition to the file system, the Windows registry, and network characteristics. Memory analysis has been shown to be an effective and strong analytical method that may be used to efficiently investigate the behavior of malware. It is the process of obtaining different objects by evaluating a memory image that has been dumped from a system that has been infected with ransomware. Ransomware detection. The techniques of detection ransomware is the machinery that has to be put in place in order to uncover and identify the harmful actions that are taking place inside the files that are being investigated. Therefore, employing three different techniques to malware detection that are signature-based, behavioral-based, and heuristic-based. A behavior-based ransomware detection system examines an item in terms of the actions it intends to do before the object can actually carry out these behaviors. Signature-based is the most straightforward and efficient method of identifying known forms of ransomware. The process of checking inbox files for previously determined viral signature, which is known as signature detection. Behavior-based ransomware detection system divided into four types: anomaly-based, specifically based, similarity-based, and machine learning-based. In the literature survey, we can see here Wang et al. Proposed a Markov model, logistic regression, random forest algorithm, natural language processing to detect ransomware. And he used the portable executable files as a dataset that contains 2,507 ransomware and 3,886 BNM files. And they used API calls as a feature that have been collected using dynamic analysis. And this work got 97.3% accuracy. Kamas proposed Weka GUI as a post, bagging, rotation forest, and random forest. The dataset was a portable executable files. You can see here the numbers of ransomware and BNM files that used. Kamas used byte level as a feature and got 97.74% accuracy. Osharani et al. Used support vector machines random forest GVTA to detect ransomware in network traffic, and they used URL, IP addresses, web pages as a feature, and they got 98.45% accuracy. Bastine proposed SVM detection tree, random forest, and TNN for detection of ransomware. They use DLL and API calls as a feature that can be got by static analysis and dynamic analysis as well. And they got 94% accuracy. Zahora et al. Proposed an approach with random forest, support virtual machine, and logistic regression for detection ransomware in Windows system. They used OB code as a type of feature, and they got 93% accuracy. Maso Mikhail proposed an approach with decision tree, random forest name-based logistic regression, and neural network for detection ransomware in Windows system, and they used the file headers as a type of feature that goes by static analysis. So we are proposing a model that contains hybrid analysis and machine learning techniques. First, we use static analysis to extract the file header of an object. After that, using dynamic analysis to run the executable files in safe environment in order to extract the API calls. After that, using machine learning for the classification process, and this model will be able to distinguish between ransomware and benign files as well as between ransomware and other malware. This is the references. Thank you all.
Okay, so it was by Aritra, right? Aritra Mukherjee.
Yes, sir.
So Aritra, anyway, it was a nice presentation, and seems like work is quite relevant considering the security issues people facing nowadays. So can you tell us a little bit about your data? It is classification, I mean labeled data or unlabeled data?
Yes, sir.
Arit,
Sir,
your data is
presentation, Mr. Akram Ali.
This
Barwani.
is Akram
labeled
presented by Akram.
okay. So tell us about your data used in the work. It is labeled data or unlabeled data?
It's labeled data.
Labeled data, right?
Yes.
So how many classes were there in the data? How many labels, I mean?
3 classes.
Three
Being a
classes.
normal software, ransomware, and other malware in one class.
Now, Akram, are you Akram, right?
Yes.
Akram, can you tell us, suppose that in your data set, thousands records are there, and maybe 900 records belong to the ransomware label, and rest of the 100 records belongs to the remaining 2 labels. And you are applying some models, to measure the, let's, to find the best model to predict the accuracy. So suppose that, most of the models, giving high accuracy, and one model is, let's say, giving very close to the highest accuracy, but precision and recall values are better in comparison to the model which is giving highest accuracy. So which one you will prefer, I mean which one you will suggest to use for this problem?
I will use the one has highest accuracy.
Why? As per I have presented the scenario, why you will use the one which is giving the highest accuracy? Suppose that one model is giving 99 accuracy and one is giving 98.9, and precision and recall of the one which is giving 98.9, its precision and recall is better in comparison to the one which is giving 99% accuracy. Then why you will use the one which is giving the highest accuracy? Why not the one which is giving 98.9 or vice versa of it? Do you have any idea about this kind of scenario?
No, sir.
Okay, so further, what is future perspective of your work? I mean, how you can extend your work?
Actually, my work is classification. The major classification is between ransomware and other type of malware.
What was the data size?
959.
959 records, right?
Yes.
It was a structured data, right?
Yes.
Can you define what is the difference between structured data and unstructured data? Okay, Akram, it is fine. Whenever you are going to apply some machine learning models, or maybe you are using some data, so at least you should be aware about the structure of the data, nature of the data, and maybe sometimes when we are aware about the nature of the data, then accordingly we can think about what pre-processing steps are required. So you should explore, in these, you should explore these concepts to do your research work better, the one you have presented here. Anyway, that's all from my side. It was good work.
Okay, no question from my side. Can we go for the next sir?
Okay, sir.
Okay.
Okay, sir. Now, next presentation, we have the paper ID is 5651. Customer churn analysis for live streaming e-commerce platform by using decision tree method. The author, Chia Yen Lim.
Good day, ladies and gentlemen. My name is Dr. Lim Chayan from University Science Malaysia. Today it is my pleasure to present a paper on behalf of my research team, which entitled Customer Churn Analysis for Live Stream E-commerce Platform. The paper ID is 5651. So the research team comprised of my research students, Ao Sia Shi from University Science Malaysia, together with me from School of Computer Sciences, University Science Malaysia. And the third author is Dr. Ang Sao Long from Tunku Abdul Rahman University of Management and Technology, Penang branch. For today's presentations, I will focus on these few areas, such as the research background, problem statement and objective, related data science technique, related work, research methodology, results, and also the conclusion. First, let's look at the research background. So as what everyone knows, COVID-19 pandemic has accelerated the growth of e-commerce. In particularly, we know that US e-commerce sales surged by 219 billion from the year 2020 to 2021. What about in China? The e-commerce markets would even reach $1 trillion in 2020 from 862 billion in 2019, based on an economic prediction. And we know that live streaming e-commerce is now a new business model and business trend. However, the competition is getting more intensive. And for this research, we are particularly research into a case study involving a China-based company. This company has established for more than 10 years with around 100 employees. The company sold business products such as electronic devices, home applications, OEM products, and etc. Traditionally, the company sold their products on traditional e-commerce platforms such as Taobao, Tmall, and Jingdong. And later on, they moved to live streaming e-commerce platform, but the business performance was not promising. As such, we looked into the problem statements which encountered by the company, which is the company actually didn't know how to predict whether customers will stay or leave with any prediction models that we are aware of. And secondly, what are the key factors related to the customer churn models? And this leads to the research objective for this paper, which is to identify a suitable classification model for customer churn prediction. So let's look into the related data science models that were used in this research. Firstly, we have this K nearest neighbor, KNN. KNN is a basic classification model that finds the K value that are close to a specific value in the training data set based on a supervised learning approaches. So we have different type of K values from big to small. The second data science models that we use here is decision tree, or we call it the DT. It is a classifier which keeps on dividing the data set as in recursive algorithm into smaller sets based on the certain tasks performed at each node on the tree. So they will have different depth of the trees to represent the different areas and also the nodes for the attributes. And the third data science models that were related in this research goes to Nails-Beers. We call it the NB. It is a type of supervised learning model which based on the assumption that each of features is independent and equally important. NB is also based on the Bayes theorems of probability. And from the research that we have reviewed, there are some researchers that actually conducted data science model predictions for different type of data, such as Kraljevic and Gotova predict telecom telecommunication company performance based on three algorithms such as neural network, logistic regression, and decision tree. And it was found that the decision tree has the highest and best prediction performance of 90.9. Later on, for Shaban et al. 2012, they also predicted mobile service performance by using neural network, support vector machine, and decision tree. And it was found that the neural network and support vector machine has equally good prediction performance at 83.7%. And for Kiri et al. In their research in the year of 2013, where they also predicted data on telecommunication service customer churn, from Bayes network and decision tree models that were used, the best prediction performance goes to Naive Bayes. And lately, we saw a research from Murchie and Ertz in 2022, where they performed prediction on online gambling company on customer churn. They use recurrent neural network, and the prediction performance is 83.7. So this research, all this research actually showed that in different scenario, different algorithms will perform differently. That is why we would like to perform more than one set of the classification models to determine which is the best for the scenario that is used for this research context, which is the live stream e-commerce company. Right, let's look into one other research methodology. So this research basically would split into 5 processes. They are the business understanding, data pre-processing, modeling, and evaluation. In the first process, business understanding, we need to explore and propose the best, and we know that we need to explore and propose the best classification model to predict customer churn for an e-commerce company based on their business on live stream. And in the second steps, we will need to understand the data set that will be used for this prediction model. So we are going to use 5,600 records from the company sales database, which comprises 19 customer attributes such as the customer ID, tenure, preferred login devices, other demographics such as the age group, the gender, order count, and also some sales activities, sales records, as well as some churn data that is captured by the company. And in the third process, data pre-processing, there are 2 steps which are involved. In step 1, missing value analysis was conducted, and as the outcome, only 3,764 rows are applicable or available, or valid, with 19 columns for modeling after null value removal processes. So this will be the final data set that we use for this research modeling. And in a step 2, from these 19 columns of 19 attributes, selection of attributes were conducted using correlation heat map. And attributes that were found highly related to the customer churn are the tenure, preferred login devices, city tire, warehouse to home, marital status, age group, day since last order, number of streamers followed, satisfaction score, and complaints. So these were the attributes used in the prediction model. And in the step 4, for the modeling, 3 classifiers would be used. They are the KNN with different numbers of nibbles, decision tree with different numbers of tree depth, and naive Bayes with various types of probability models. And the cleans dataset, which comprise of 3,774 data rows, will be split into a training set of 70% and a validation set of 30% to evaluate the quality of the model. And lastly, to evaluate the model, 3 evaluation metrics were adopted. They are the precision, recall, and analysis. All right, let's look into the model evaluation for 3 of the classifier models that were adopted in this research. Firstly, let's look into KNN. So different number of neighbors were used to run the KNN algorithm based on the outputs that were used as shown in this graph. When K is 2 at this point, KNN algorithms generated the highest accuracy score of 0.9450 around that, while others shows a lower numbers, or we could say that the higher the number of K, the lower the number of accuracy score. And for our second evaluation model, the decision tree, different depth values of decision tree are used to run the decision. Basically, we run from the tree depth of 3 to tree depth of 16. So we found that when the depth is 14 at this juncture, decision tree algorithm generated the highest accuracy score with around 93.5%. And lastly, we go for the naive Bayes model. The probability model that we use to run this algorithm, including the Gaussian, multinomial, and Bernoulli. And we found that all three algorithms produce the same accuracy, which is the 85.43 for all the algorithms. As such, for this research, naive Bayes algorithm is executed by using the Gaussian model. Right, by comparing the three prediction models that we presented just now, which is the DP, KNN, and NB, we found that decision tree has the highest accuracy, which is 93.6% in comparison to 92.7% of KNN, and naive Bayes has the lowest accuracy, which is only 85.4%. So with this outcome, we concluded that decision tree would be the most appropriate classification model to perform customer churn analysis for this live stream e-commerce platform, in particularly for the company context that we will research in it. And as the future work, we would like to propose that visualization and pattern analysis approaches could be adopted to explore the classified customers' churn and non-churn groups in depth, to understand the customer threats and demographics, and to derive better promotion and marketing strategies to retain the customers. And these are some of the references that we will use in this presentation. And that's all for this presentation. Thank you for listening. If you have any comments or feedback, we welcome you to contact us by emailing to me, cylim@usm.my. Thank you very much. Have a nice day.
Okay, so it was a nice presentation and seems like, very good piece of work. So Dr. Lim, I have a few queries related to your presentation. So first,
yes, please.
Any suggestion to the company as per finding of your work, so that company can stop this churning of the customers?
Yeah, sure. Right. So basically, this is actually a field work that we put it in industry collaboration with a company from China. And the company is actually really looking forward to get the prediction model working, and it should be implemented now. So what we actually have started the future work, which is to look into the churn and non-churn model by using the selected criteria from the prediction model to compare where is the classified model that they should focus to, especially doing the marketing event. So it is like a way to help them to identify customer that they should focus to minimize their promotion and marketing costs. That is what we are doing now.
Okay, fine. And a few questions related to the model you have applied. So how you have chosen the K value in KNN model, K nearest neighbor model? How you have chosen the K value? Just by running your model multiple times, or some techniques you have applied to choose?
Yes, we actually running multiple times for different K value to see the trend. And as you can see in the graph, right, when the K is actually running higher in that, then the accuracy actually goes down.
So that means the one which was giving the higher accuracy, you have chosen that one, right?
Yes, correct. Yeah, that is the technique.
Okay. And a few concern about the decision tree, as we know that there are several variants of decision tree. So which variant you have applied in your model? If you remember, one variant is based on entropy, another one is based on Gini value, and there are some other modifications of decision tree, like based on information gain. So which one you have applied in your model to find out the accuracy of the prediction accuracy, in fact?
Oh, okay. To getting the prediction accuracy, actually we referring to the accuracy in the confusion matrix. That is the one that we refer.
No. I think you didn't get my question. I'm asking about. Let me simplify this question. Decision tree have some variants like cart, ID3,
okay.
ID 4.5. So which one you have applied in your model, in your work?
Oh, for this one, we actually use the 4.5, the one.
ID 4.5.
Yes,
So what is the criteria when we are let's growing are building the tree decision tree? Like when we apply the cart algorithm, so we use the entropy. When we apply the ID3 algorithm, so maybe we use the Gini value. So in ID 4.5, which criteria you have used to build the decision tree?
Okay, the criteria, if you can see from one of the slide, actually we have in the pre-processing we actually have highlighted 1, 2, 3, 4, 5, 6, like 10 out of the 19 criteria has been pre-processed, and we actually just apply the
I
smaller
think
set of
Dr. Lim, I think you have not explored the variants of decision tree, and I'll suggest you to explore the variants. Maybe you'll get the better accuracy. Right now you are having 93 point something. So when you'll try the variants of decision tree, yeah, maybe you can try the random forest ensemble model that is based on decision tree. So it will improve the accuracy of your let's prediction accuracy of whatever data set you have used. That's all from my side. Thank you.
I will take your suggestion. Thank you very much. Thank you.
Okay, thank you. No question from my side. Okay, thank you, Dr. Lim.
Thank you.
Okay, can we go for the next presentation?
Yes, sir. Now we have this next presentation. Paper ID is 6092. The author is Jayant Kumar Ray. Paper title is Estimation of Reliability, BER, BLER, and Throughput during the coexistence of 4G LTE and 5G NR.
Good morning to all of you. My name is Jayant Kumar Ray. I'm a research scholar of Sikkim Manipal University. My paper topic is estimation of reliability, regenerate, block rate, and throughput during the coexistence of 4G and 5G NR. I want to give a lot of thanks to ICACIS 2023 because this committee has selected our paper. So these are the contents which I want to say you. First is the abstract, introduction, plan and progress of the coexistence of 4G LTE and 5G NR, test outcome, summary and conclusion, acknowledgement, self-references. Abstract. The coexistence of 4G LTE and 5G new radio gives a great opportunity in the real world. Chance of interference of the signal, throughput of the signal will reduce due to interference. To reduce the interference of the signal, the oscillator frequency of 4G LTE is kept fixed and that of 5G NR should be variable. Where the oscillator frequency of 4G LTE and 5G NR are equal, similar or same approximation value, then there will be more VLER, VR and less throughput. To reduce VLER and VR, the frequency of 5G NR should be changed and kept in such a situation where there will be more throughput. Analysis of VLER, VR and throughput indicates the reliability of the signal. Introduction. The radio spectrums have much more increasing demand. Due to the small fixed range, there is a limited range of spectrum. Spectrum sharing is one such method which is being used to share the limited range of spectrum between different users. Dynamic spectrum sharing is a technology in which both 4G LTE and 5G NR in the same frequency are deployed. Ericsson spectrum sharing provides the operator to execute LTE and NR simultaneously on the same carrier frequencies. With the help of ESS, migration from 4G LTE to 5G NR is becoming simpler, efficient, and faster. It is not necessary to remove LTE V2X where NR V2X will be launched. Hence, there will be coexistence of LTE V2X with NR V2X. Plan and progress of the coexistence of 4G LTE and 5G NR. System view software is utilized for simulation purpose. The coexistence of 4G LTE and 5G NR is designed. Spectrum areas are collected both in 4G LTE and 5G NR where the spectrum can be analyzed. The oscillator frequency of 4G LTE is kept fixed, whereas the oscillator frequency of 5G NR should be changed. This is a simulation diagram which I create using system view software designed by Keysight Technologies. Now, see that in the upper part we already include the 5G NR, in the lower part we include 4G LTE. Both of them, the spectrum, the two spectrums are connected. Suppose I'm telling you this is one oscillator. The oscillator's bottom is kept fixed. The oscillator frequency over here is 4G LTE is 1.901. For the oscillator in the 5G NR should be changed. It should be varied from 1.892 to 1.908 gigahertz. These are the essential parameters for 4G LTE and 5G NR. The serial number is given with parameters. 4G LTE for 4G LTE transmission is LTE downlink, for 5G NR is NR downlink. The oscillator frequency for 4G LTE is 1.901 and for 5G NR is 1.892 to 1.908 gigahertz. Oscillator power is 70 dB, whereas for 5G NR is minus 41 dB. Sample rate 20 megahertz and also 5G NR is 20 megahertz. Cyclic frequency for both of the for 4G LTE and 5G NR are normal. Source bandwidth is 5 megahertz and for 5G NR is 50 megahertz. Modulator in phase quadrature, both of them is in phase quadrature. IQ is the short form is IQ. Demodulator is in phase quadrature. Receiver is LT downlink baseband receiver. Carrier frequency is both of the same, is 1.901 gigahertz. Multiple input adder is applicable for 5G NR only, but 4G LTE is not applicable. Transit time interval is 8 microseconds. Different situations. Just I want to show you 4 situations. The color of the two spectrums are denoted by purple 4G LTE and green 5G NR. From figure 2 to figure 5, y-axis specified the power of the spectrum, and whereas the x-axis specified the frequency. Power of 4G LTE is denoted as S1 underscore power, whereas the power for 5G NR is denoted as S2 underscore power. F1 is denoted as oscillator frequency for 4G LTE, which is fixed at 1.90 GHz, and F2 is the oscillator frequency for 5G net radio. VLR is block error rate, VR is beat error rate, reliability R is denoted as 1 minus beat error rate. Situation 1. For here, the frequency, oscillator frequency for both the cases are same. So that's why what will happen? There will be the problem of interference. Beat error is maximum, VLR is maximum, and throughput of the signal is what? 0. That's why you can able to say there will be no reliability. In the situation 2, there is a large difference between frequencies of 5G NR and the 4G LTE. What will happen? There will be no problem of interference. The problem will not be probable. Beat error rate becomes minimum. Block error rate becomes minimum. Throughput of the signal is 246.9 Mbps. Hence, we say that the signal is reliable. Hence, we say there is a presence of reliability. Situation 3. There is also huge difference between the frequency of 5G NR and 4G LTE. So over here, problem interference will not be probable. Beat error is minimum, block is also minimum, through signal is maximum. So 246.9 Mbps. Hence we say that there will be reliability. But I'm telling you, situation 2, there is situation 3, frequency are different, but I'm telling you, most of them the output is same, but you have seen that the spectrum location is different. Here the spectrum for 5G is located at the left hand side. Over here for situation 3, 5G is located at the situation at right hand side. Situation 4, the frequency difference between 4G LTE and 5G NR is not very large. The problem of interference will be probable. Beat error is because maximum, block error is 1, becomes also maximum, is also maximum. Throughput of the signal is 0. Hence we say the signal is not reliable. Next comes the variation of beat error rate, block error rate, reliability, throughput, and throughput fraction with frequency. The range of oscillator frequency for 5G NR is varying from 1.892 GHz to 1.908 GHz. The variation of frequency specifies the value of beat error rate, block error rate, throughput, and throughput fraction in the coexistence scenario mentioned in the table 2. According to table 2, variation of throughput and reliability are opposite to BR and VLR. Why I say that? Because I'm telling you, with the increase in BR, VLR, throughput is decreased. With the decrease in BR, VLR, throughput is increased. I already mentioned it in table 2 by the analysis. From table 2, variation of different parameters like BR, VLR, throughput fraction with different oscillator frequencies of 5G NR are specified. See here table 2. In the mean of, I'm telling you, 1.892, what you mentioned over here, beat error rate is maximum, block error, beat error is minimum, block is also minimum, here the reliability is high and throughput is also maximum. So over this point, the signal is reliable, throughput fraction also. I'm telling you serial order, if you want to watch from top to bottom, what will able to see, the beat error rate start to increase, reliability start to decrease, block error also start to decrease, then throughput also start to decrease because frequency comes to closer, because frequency will move, the spectrum will move from left hand side to right hand side, it will increase. So 1.89 to 1.908. What will happen? It will increase. So that's why what will happen when it comes closer, then what will happen? The throughput is trying to decrease and becomes 0. And block rate becomes maximum, beat rate also becomes high, and reliable is not efficient for the user, for the devices, and not applicable for the devices. Over here, throughput is in the unreliable condition. This is also unreliable condition. This is also unreliable condition. Over here, you are going to see that the block error start to decrease, beat error start to decrease, reliability start to increase, throughput also start to increase, and start to increase and becomes, over here becomes maximum. The last is the maximum. These are already plot 4 graphs, reliability versus frequency. See that here in the left side and the right side already will be used part because reliability is high, and the middle part is totally unreliable because it will not used by the user. It is not applicable. Over here in the middle portion, block is also high. Same case, throughput is also, the throughput is high in the left hand side and the right hand side. In the middle portion, throughput becomes 0. Throughput fraction also becomes 0. 0. There. The summary and conclusion. Many organizations in the world invested huge expenses for the construction of 4G LTE technologies. By launching 5G technologies, if 4G technology is totally removed, then the organization will face a great loss. In order to maintain the business strategy, 5G technology will be constructed by keeping the existing 4G technology. The concept of the existing 4G, LTE and 5G era is existing in the world. The problem of interference is due to the coexistence of 4G, LTE and 5G era. A certainly developed system with software where the presence of both 4G LTE and 5G NR. The frequency of 4G LTE is kept fixed, where the frequency of 5G NR is always changing. Reliability or unreliability of the signal can be estimated by varying the frequency of 5G NR. These are the references. So thank you very much to all of you.
Okay, Jayant. What is throughput? Jayant. Who is the author of paper?
Hello, sir. Yes. Good morning, sir.
What is throughput?
Throughput
Can
is
you define throughput?
Yes, how much beats per second is is already emitted by the device. It's already
Okay.
my throughput is measured in megabits per second.
Okay, then most of the work you have so that your throughput is 0 many times.
Yes. Because already
Okay.
due to the interference.
Okay. Then what is the reliability of your work? If
Reliability when throughput becomes maximum and beat error rate becomes minimum.
No, throughput is 0. Then reliability of work.
Reliability will be totally 0. It will be 0.
And you have more shown that throughput is 1, then 100% no interference in the signal. How it possible?
Throughput is 1 where?
In the graph, in table you have shown that there is throughput is 1.
Throughput is 1 and there will be value of the reliability because already reliability is 1 minus BR.
Means
So
there is no interference in your signal.
Throughput is 1, then there will be if the throughput is 1, then there will be no interference. There will be no interference. Yes.
And
yes,
in one table you have shown then for the 4G you have approximate 41 decibel and minus 17 decibel for power oscillations.
Yes.
It is possible.
Minus 41 we saw for 5G NR. 5G NR is minus 41 and for
in one place you shown that positive value and negative value one place.
Yes, already I have done while doing the working using software simulation. I've got it. This type of
Which simulator you have used?
Huh?
Which simulator you have used for the
system view?
Okay.
Because whatever I got it, I've done it. Because already because they live in the same level. Because already if I give the power of the oscillator, 5G NR is 17 dB, and if it is 17 dB, what they watched, then they are not in the same level. 5G NR level should be high. That's why when I've done it, because I've gone to various parameters, then I have seen that this they are in the same level. Then I calculated it.
Okay, Sunil.
Yeah. Thank you, sir. Jayanji, it was seems like work is very relevant to the current scenario because people have started using the 5G technology. So can you tell us something, the architectural difference between 4G and 5G?
Architectural difference, there are various differences because already seen in the architectural difference already in subcarrier spacing only 50 kilohertz is 50 kilohertz is subcarrier spacing for 4G LTE, but 5G and it will be more than 15 kilohertz kilohertz subcarrier spacing.
So that
There are
means,
5 numerologies because with the increase
as
in
I
numerology
have
as what.
explored, Jayant,
Yes,
as
yes.
I have explored this area, 5G is based on millimeter wave, right?
Yes.
And suppose that a user is using a cell phone which is supporting the 4G services or 3G services. So is it required to move for the new device for availing the this coexistence facility of 4G and 5G and R for internet?
Internet already basically according to the user requirements, because I'm telling you already seen just a few days ago already seen. I have
Okay.
already gone for the various articles for news articles. Already seen that India most of the parts already under 3G, because already that's the time suddenly 5G will not come because from 3G to 4G most in the most remote areas, I'm telling you, most remote areas in India. Then the government is trying to facilitate 3G to 4G. Then after that with 4G, because that's why I'm giving the 4G will be not totally removed. It will be kept in constant, and 5G will be variable.
Same thing I am also talking about. It is with respect to the user. For example, a user is having nowadays whatever the cell phone we are having that is able to facilitate the, let's say, 4G, 3G, or maybe 2G. We are able to use the services. These three vertical services in a single cell phone device, depending on the availability of the infrastructure and kind of things.
Lack of
But
infrastructure, most remote areas, yes.
as you have already stated that there is a huge architectural difference between 5G and 4G. So suppose that someone is going to buy a new cell phone for availing the 5G services. So is it possible to avail the 4G and 3G also on that cell phone, or two cell phone will be required to avail these services and two SIM cards will be required? Have you explored this perspective?
Yes, I have explored it. I've
Yeah,
seen that
please.
4G, I'm telling you, already it's seen that 5G is basically the advancement of 4G. 5G is basically the advancement of 4G, because already I'm telling you there is a glass difference between 4G and 5G. Okay, so 4G and 5G main difference is that.
Jayan.
Yes.
As for the architectural changes, you can see that 4G. What is the frequency band we use for 4G, and frequency band for 5G? Because 5G is based on millimeter wave concept.
Because already I have band for 5 megahertz for 4G and 50 megahertz for 5G, because in my parameter table I use it. 5 megahertz for 4G and 50 megahertz for 5G. I have used this with in this infrastructure.
So that means, as per your findings, a single device can handle these 5G and 4G services, right?
Should be developed in such a way, because already
have you used 5G network in your cell phone?
No. For 5G is totally
So
different.
it is just a theoretical analysis, right?
Yes.
Okay, fine. That's all from my side. Thank you very much.
Thank you, sir. If anybody have another, because I want to try myself to develop the same infrastructure in physical platform.
Yes, Jayant, actually it is very relevant question from the user's perspective, because as I have seen that architectural difference is used between 4G and
Yes.
5G.
Yes,
So
because
you have already mentioned that these two techniques are coexisting. So using these coexisting technology over the same cell phone is going to be quite tedious. That's why I had these questions. And anyway, it was nice work. Yeah,
Okay,
Dr.
thank you, sir.
Garima, please, you may proceed for the next presentation.
Okay, sir. Okay, sir. Now, next presentation, we have the paper ID 6861. Author is Anish Pratap. The paper title is Exploring the Future of Edge Computing, Advantages, Limitations, and Opportunities.
Hello everyone, welcome to my presentation. My name is Anish Pradeep from Tashkent, Uzbekistan, and I would like to discuss about my topic, exploring the future of edge computing, the advantages, limitations, as well as opportunities of using this technology. Edge computing has been used as a distributed computing paradigm, and it enables data processing and also to analyze the data closer to the source of the data itself so that it can provide higher bandwidth, low latency, and can also support better privacy and security. Nowadays, there is a lot of use of IoT devices, and it's being used in healthcare, smart cities, and industrial automation. Edge computing can help in reducing costs and also analyze real-time analytics so that decision-making can be made quicker and securely. Related works where edge computings are being used. First one is fog computing. Fog computing is an edge computing that extends cloud computing to the network's edge because it's much more efficient than cloud computing. It enables data processing and analysis to be performed on the devices closer to the data source. Next one is edge analytics. It involves performing data analytics and processing at the network's edge, enabling real-time decision-making and reducing the need of data transmission through the cloud or over long distances. Mobile edge computing is a type of computing that focuses on mobile devices such as smartphones and tablets. It enables data processing and analysis to be performed on the device itself, reducing the need of data transmission so that it can be more secure and focusing on privacy. Last one is edge AI. It involves deploying artificial intelligence algorithm and models to the network's edge so that real-time decision making can be made by reducing the need of data transmission over long distances. It's been used in a variety of fields such as driverless vehicles, factories, automation, etc. Edge security focuses on securing edge devices and networks from cyber attacks and vulnerabilities. It's done by deploying various measurements such as encryption, access control, and threat detection.
Okay, sir.
The main benefits of using edge computing, it has reduced latency so that it doesn't have to send data over long distances. Increased bandwidth to use
Excuse me, Mr. Anish. Please skip
of
the
network resources
part.
and also focusing on privacy.
Directly go to the conclusion. Just directly go to the conclusion.
Do I have control of the system? I think it's the video being played. I don't have control how to skip it.
Yes, sir. Yes, sir. We are doing, sir. Please.
Okay.
Paritru, sir.
Yes, ma'am.
Sir, please move ahead
Just
to the
go to the
presentation.
conclusion part because these are the very please. Because these are the very basic terms and it is not required to let's have time over it.
Okay,
Just
okay, sir.
present the summary what you have explored in this work.
Okay, sir.
And security, so that's data generated and it should be analyzed. This is visual to protect sensitive cloud.
Sir, this side, okay?
Yeah, skip it. It is not required.
Sorry, edge computing accuracy comprises
last 2 minutes of the presentation.
Yes, sir.
Just skip initial presentations. Last 2 minutes is required to listen. That's it.
Okay, okay, thanks.
examine data from to control. It's also been used in smart cities to analyze data and decision making, such as traffic management to control the traffic and reduce congestion. How the companies and industries can analyze which fashion or which trends are being popular at the moment based on the customer behavior, and they can also use this data to promote recommendations to the users. In supply chain management, edge computing can also be used to track real-time logistics and operations, so that they don't have to hold a lot of data based on the data collected from the user and how much products they're being used. Those data based, for example, some seasons, let's say a rainy season or winter season, some products are being used more by the customers. So based on that data, the logistics operations can be efficiently managed. To conclude, edge computing is a powerful computing paradigm that can improve latency, bandwidth, privacy, and security, which technology is smart cities, industrial automation, and various factories. There are several challenges that we discussed in this presentation because of the lack of technology, and within the coming years, we'll be able to solve these issues and use the full potential of edge computing with its benefits. Thank you for giving me the opportunity to discuss my paper. If you have any questions, please let me know. Thank you.
Okay, Anis, it was a nice presentation. I have a few questions related to your this title of the work. As you have mentioned that you are going to explore the let's say future aspect of edge computing. So what are your findings? I mean, what did you find after exploring the related work of the edge computing?
Thank you, sir, for the question. The main focus here was, even though edge computing is a hot topic, and the main idea I was looking for is how it can be applied currently and for the future for relevant industries, such as for autonomous vehicles or smart cities or retail. I was always trying to explore how these industries can embed this edge computing so that they can be more efficient. When I say efficient in terms of, let's say, for supply chain management, maybe their cost or reducing delivery time. The more exploration was how it can be applied on these industries. And then I moved towards if edge computing is amazing, why are these industries not implementing them? So I went through some of the works and find out key limitations why it's not being used a lot. Mostly the main important is resource constraints. For example, these edge computings and setting the systems need technical skills by IT companies, and usually these industries are not knowledgeable enough to set up these.
Nowadays, intelligence-based system like machine learning-based and deep learning-based models are being used for the automation. So, over the availability of these techniques, you are exploring that how edge computing is going to be relevant. Although I think edge computing is not very new. Edge computing is not very new, and there are tremendous number of papers has been published already. So, are you doing PhD student?
No.
So, have you completed your PhD, right?
No, I'm trying to pursue PhD now. Okay, so I want to try to pursue PhD on this topic. So I have been reading a lot of materials regarding this. And this, I agree with you.
You should move, I mean, you should develop some concept related to the integration of technologies, because as you have presented, the exploration of edge computing, it is very elementary. Right? So just try to explore some concepts which are being correlated with the edge computing, or maybe a hybrid concept can be developed for to improve the let's say applications of where you are going to apply this edge computing. It will help you a lot, right?
Okay, I agree with you. You're saying that I should focus more on one particular industry and then try to find a relevant solution for that problem, rather than going through all industries
Okay,
together.
okay. That's all from my side.
Okay, thank you.
Okay, Anish.
Yes. Yes, sir.
In your survey, you can find any industry which there is implemented this type things.
Mostly, it's most of the industries being popular is supply chain management, like or maybe logistics company where there's a lot of
Which is the most popular type area where this is implemented, and what is the implementation cost for the company?
From my review analysis, I think it's a logistics company because, as you know, online shopping and e-commerce have been very popular nowadays. And when people order some products online, they would like to check where is their product, which city, which location, which time. So companies are trying to create a network of systems where they can have real-time feed of this information. But for me, I want to try to implement this on, let's say, for agriculture or for checking the freshness of fruits or vegetables, or monitoring them so that we can reduce the wastage of food.
Then what is the implementation cost according to you if when you are going to implement?
At the moment, I cannot give you an exact number. It depends upon the industry, depends upon the scale, depends upon what kind of sensors and technology they're trying to use, and how many, let's say, departments are involved within one company or industry. It again is based on scale and cost of the sensors required. Some industries need very simple sensors, like they can even use Arduino sensors, but some of them need high-tech sensors and information processing.
Okay, thank you for presenting. Okay, can we go for the next presentation?
Thank you, everyone. Thank you for your support. Thank you.
Okay, thank you so much, sir. So now our next paper presentation is paper ID is 8197. Author is Mr. Sandeep Kumar Dey. Paper title is A Survey on Designing Efficient WSN Using Duty Cycle Optimization.
Good morning, everyone. Myself, Mr. Sudeep Kumar De, is here to present the conference paper titled as A Survey on Designing Efficient WSN Using Duty Cycle Optimization. This is the contents of our paper. Introduction. A wireless sensor network is a group of wirelessly linked, geographically distributed tiny wireless sensor nodes that can sense a variety of physical measures from their surroundings, and after translating them into electrical signals may send and receive a finite amount of data to other nodes or a sink node in the network. A battery-centric WSN may quickly dry up if the usage of the energy is not prioritized. One of the prime challenges in the designing of a WSN network is the minimization of energy consumption of the network. Secondary challenges can be minimization of delays, improving throughput, preserving the quality of service, etc. The duty cycle management can address the primary as well as the secondary challenges of the WSN. This research addresses the impact of duty cycle in WSN through a survey of several duty cycle designs. Duty cycle optimization can handle the issue of idle listening, overhearing, and retransmission of colliding data, in addition to saving energy by algorithmically shutting off its radio on the WSN nodes. The existing duty cycle management strategies in designing efficient WSN can be mainly classified as synchronous, asynchronous, and hybrid duty cycle management strategies. The synchronous duty cycle maintains a predetermined periodic sleep pattern across neighboring nodes such that sensors can sleep on a regular schedule to save power consumption. The synchronous duty cycle can be further classified into fixed time sleep schedule and an adaptive time sleep schedule. In this strategy, the sender node sends RTS packet to the target node. The RTS packet reaches the intended node as well as the unintended nodes. The target node sends CTS packet in the network, which also reaches the sender as well as the unintended nodes. In fixed time sleep synchronous duty cycle, the non-targeted node has to overhear the packets. A contention-based synchronous fixed-time sleep schedule protocol SMAC or the sensor MAC was introduced in 2002. Nodes in SMAC regularly sleep to minimize the idle listening time. Because the sleep and listening intervals are fixed and predetermined, the algorithm performs less effectively under varying traffic loads. In SMAC, due to lack of synchronization between nodes, the node enter into the sleep mode before receiving the packets from surrounding nodes. This is known as the early sleeping problem. The SMAC protocol is suited for the situation in which the sensor node can tolerate longer idle period and low or fixed traffic load. The problem of overhearing can be reduced by using the adaptive time sleep synchronous duty cycle, where the non-targeted node can enter into the sleep mode whenever it detects the RTS signal not intended for itself. From the figure, it can be observed that on receiving the RTS, which is not intended for that particular node, it immediately sleeps. As it reduces overhearing issues, the adaptive time sleep plan is more energy efficient than the fixed time sleep schedule. Examples of adaptive time sleep schedule protocols are TMAC, PMAC, DMAC, QMAC, RMAC, AD, CC, etc. The timed out MAC or TMAC protocol was proposed to improve the performance of SMAC protocol under fluctuating traffic loads. The core concept of TMAC is to minimize the active period based on the traffic circumstances. Unlike the SMAC protocol, the early sleeping problem is also tackled in TMAC, but the TMAC has low throughput, increased delay, complexity, and scaling issues. The pattern MAC or the PMAC protocol optimizes the wake-sleep time based on the traffic of the node and its neighbors, and the nodes that are genuinely active in the communication wake up often. This method assists in the conservation of energy in non-communicating nodes. But if neighboring nodes could not exchange the schedule pattern with each other, then nodes will not be able to communicate. In that case, idle listening can be observed. PMAC protocol delivers higher throughput in high traffic and saves more energy in low traffic than the SMAC protocol. The DMAC was introduced to improve the delay issue of SMAC and the TMAC. DMAC introduces overflow slots. Nodes that lose the contention do not have to wait for the next upward flow but can attempt again in an overflow slot schedule. The overflow slot boosts the capacity on demand, enabling DMAC to adjust the traffic load automatically. However, the DMAC, like the SMAC and the TMAC, must awaken all WSN nodes during every duty cycle. This is not an energy efficient approach. The query-based MAC or the QMAC protocol achieves the minimum latency through adaptive scheduling and energy efficient data transfer by activating only the nearby nodes during the packet transmission. According to the simulation data, QMAC outperforms the SMAC. In 2009, Chio et al. Also proposed a QMAC protocol that adjusts node sleep periods based on traffic loads and allows sensor nodes to sleep longer in low traffic to conserve the energy. The simulation results show that the suggested QMAC saves more energy than the PMAC and DMAC while maintaining a low transmission delay. The RMAC is a routing-based MAC protocol. When a control frame peon travels from source to destination through the multiple hops, then a schedule for forthcoming packet is prepared in advance, and the nodes intelligently wake up at the predefined planned time to reduce the network latency without losing the network energy efficiency. However, the peon technique complicates the matter of packet transmission. Another adaptive duty cycle protocol called ADCC is proposed to minimize the delay as well as to maximize the lifetime of the network by introducing the feedback acknowledgement signals about the remaining energy of the nodes in the packet delivery system flow. Asynchronous duty cycle. The predetermined synchronous periodic sleep pattern among surroundings nodes in multi-hop communication is not only difficult to implement, but it may also result in significant delay. Nodes in an asynchronous duty cycle are not needed to agree on a predetermined time frame. As a result, the nodes do not have to memorize their neighbor schedules, which significantly lower the storage and energy cost associated with the schedule sharing between the nodes. The recipient in the asynchronous duty cycle knows its wake-up period but not its wake-up time. It is also stated that asynchronous duty cycle protocols are more scalable than the synchronous duty cycle protocols. Asynchronous duty cycle uses low-power listening, also known as the preamble sampling, and here nodes periodically wake up to detect the potential of transmission in the network by performing periodic channel sampling. To send data to the intended destination node, the transmitter delivers a preamble packet on the network. Depending on the approach, the preamble packet can be either long preamble or a short preamble. The recipient waits for the data to be sent after receiving the preamble packet. To ensure that the receiver will sample the channel during the preamble, the sender uses the long preamble strategy, which is at least as long as the receiver's wake-up period. The sender and the recipient exchange the data packets following the preamble. However, the large preamble packet size increases the network listening and receiving overhead and causes a considerable delay. On average, all overhearing nodes must be awake for half of the preamble transmission duration before discovering that the preamble packet is not intended for them. As a result, it increases the energy requirements. The protocol BMAC utilizes a long preamble to make sure the recipient is awake when the data packets arrive, When the channel is idle, this long preamble sending technique delivers extremely little power usage. Larger delays and overhearing are the protocol's main drawbacks. To address the drawbacks of the BMAC, the WiseMAC was introduced. In WiseMAC, instead of fixed length preamble, it uses a dynamic preamble length to reduce idle listening and as well as to reduce the power consumption. The main drawback of this protocol is low scalability in changing traffic condition. Short preamble asynchronous duty cycle. The SMAC protocol was introduced to address the long waiting time and overhearing problem. Instead of sending a single long preamble, the sender node in SMAC sends out a time-gapped series of short preambles that include the address of the intended recipient. The time gap between two short preambles enable the intended receiver to send an early acknowledgement to the sender so that the sender can send the data packet as early as possible. It reduces the latency in the network. On the other hand, on receiving the short preamble, the non-targeted recipient node sleep immediately as a solution to the overhearing and to minimize the energy consumption. A short preamble packet sending technique minimizes the network latency and energy waste when compared to the BMAC. But since more preamble packets are delivered, they may still use more energy than the synchronous protocols. To reduce the burden on the sender node, the receiver-initiated RIMAC protocol was proposed. When there is a high volume of traffic, RIMAC shows a noticeable improvement over SMAC. But the RIMAC suffers from idle listening by the senders and has a significant end-to-end latency. To overcome the problem of idle listening of the senders, another receiver-initiated protocol, LMAC, was proposed. The LMAC improves the end-to-end delivery in low traffic situations while consuming the least amount of energy. In terms of energy balance between the transmitter and the receiver, it has been found that LMAC performs better than the RIMAC. The hybrid duty cycle. The hybrid duty cycle protocol focuses on a composite protocol using multiple channel access techniques, CSMA, CDMA, TDMA, to handle dynamic traffic load in the channel, reduce latency and collision, and achieve energy efficiency. The key strength of the hybrid design is the flexibility of the contents and intensities. A hybrid duty cycle protocol, ZMAC protocol, combines the strength of TDMA and CSMA while compensating for their shortcomings. It uses CSMA in low traffic situations and switches to TDMA in high traffic situation to enhance the contents and resolution. Under medium to high contention, it is revealed that ZMAC outperforms BMAC, and BMAC is marginally superior in terms of energy. The ADB-MAC protocol reduces energy lost in idle listening by combining advertising and contention strategies. It introduced a multicasting mechanism for broadcasting data to its neighbors, which SMAC and TMAC could not support. The result demonstrates that with heavy and dynamic traffic, the ADB-MAC protocol may save energy while maintaining throughput. In this study, the authors have emphasized mainly different duty cycle management strategies like synchronous, asynchronous, and hybrid duty cycle management strategies. In case of synchronous duty cycle management, two different sleep schedules, namely fixed time and adaptive time schedules, have been discussed. And in case of asynchronous duty cycle management, long preamble and short preamble scheme have been discussed. The study will help novice researchers as well as the learners to cope with the idea of the field of duty cycle optimization. In future, one can easily explore the field and get motivation to extend the work. These are references, questions. Thank you.
I have a very
Sir, it is not audible, sir. Am I audible? It is not audible, sir.
Related to your presentation.
Hello.
That is, how your work is going to contribute over the existing work. Once again, my concern is how your work is going to contribute existing work, which is you have explored in the literature.
Yeah, sir. Question, please, sir. Your voice is breaking out. So can you repeat, sir?
Okay, fine. I'm repeating once again.
Yes.
How your explored work is going to contribute over the existing technologies, existing tools.
Okay. Okay, sir. Basically, we explored the total duty cycle areas, synchronous, asynchronous, and the hybridization. So after my study, I realized that the hybrid would be the choice that that minimizes the latency and minimizes the energy consumption. So my suggestion will be that after studying that, that if I implement it using the hybrid model, then it will minimize the energy consumption, and finally it will help to establish an efficient WSN.
Okay, fine. Thank you. That's all from my side.
Okay, thank you, sir.
Arun sir, any question from your side? Okay, thank you, sir. Now we will move to the next presentation.
Thank you.
Arun,
Thank you,
are you
everyone.
there?
Thank you.
Hello, ma'am. Go to the next presentation, sir.
Okay, sir. Okay. Now we move to the next presentation. The paper ID is 8198. The author is Dr. Prashant Wirtz. Paper title is A Novel Framework for Harnessing AI Evidence-Based Policy Maker in E-Governance Using Smart Contracts.
Good afternoon, ladies and gentlemen. My name is Dr. Prashant. Today I'm here to present a novel framework for AI-based, evidence-based policy making in the e-governance using smart contracts. So we will begin our presentation with the introduction to the paper. So we'll be starting with the abstract, then we will be going with the introduction, then we are going to discuss about the related work. Then we are going to discuss about the proposed methodology. We will be conducting our experimental results, and then we will be discussing about the conclusion that we have drawn from the work. So abstract, if we'll talk about harnessing the AI-based, you can say policy making in the e-governance has the potential to revolutionize the way that governments are formulating and implementing their e-governance policies. So by using the AI technology, governments can analyze the vast amount of data, how the extract valuable insights have been done to make informed decisions based on the evidence. So this paper basically explored the various ways into which the AI can be employed in e-governance to facilitate your evidence-based policy making. We also discusses the use of AI-based algorithms for your data analysis and prediction, enabling the government to basically identify the various types of patterns, trends, and emerging issues from the diverse data sources. So moreover, AI-powered tool can also enhance your citizen management and participation by facilitating the data-driven decision-making process and providing the personalized services. So basically, we will first of all discuss with the introduction of the paper, in which we will be seeing that government actually faces the challenges of making informed decisions and formulating effective policies in an increasingly complex and data-driven environment, where traditional methods of policy making, they often rely on the limited data, anti-dectal evidences and expert opinions, which may not fully capture the intricacies and nuances of your modern government issues. So by leveraging the AI algorithms, government can basically analyze the diverse sources of data with the citizen feedback like social media, government records to identify the patterns, trends, and emerging issues. So basically this data analyzes the policymakers with a comprehensive understanding of the challenges, needs, and the preferences of citizens that help them to make the informed decision based on the evidences. So by employing your predictive analysis, what governments can do that they can identify the potential impact of the government different policies option, and then they can identify the most effective strategies. So basically, we have proposed an approach to identify the possible gaps in that. Now, we will be talking about the related work that we have seen while going through this research. In this, various authors have been implemented the various applications for the AI in government. They have also discussed the role of data analytics and the smart governance with the application of AIs and highlights their potential in evidence-based policy making. Many of the researchers, they have explored the opportunities and challenges of various AI, you can say, applications for evidence-based policy making in the public sector as well. Some of the authors, they have specifically focused on the evidence-based policymaking, where they have been the potential benefits of enhancing the policies, analysis, citizen engagement, decision-making process with addressing the challenges like data quality, biasing, and ethical considerations. Some of them have also proposed the various models for improvising the policy analysis, challenging the algorithmic transparency, fairness, that needed to be considered while harnessing the AI governance. Now, this is a proposed methodology into which basically we have proposed a framework that has been consisting of the various technologies that have been provided for the implementation of AI-based network, you can say framework, for implementation of smart contract-based applications to analyze the, you can say, citizen-related data and all that, into which we have developed a module into which the government collective office network will be provided, that is having its own big data service centers that will be managing the intelligent archives to provide the social, public, and research-based activities that will be taking the services of the smart contracts. Further, these are the experimental results that we have considered with various factors like data governance, algorithmic transparency, ethical AI, implementation, then capacity building, then stakeholder management and impact assessment, where the key indicators we have taken and then the percentiles that we received by applying the data scores over that. These are the graphs that we have received for the displacement of various functions for result analysis of policy making for harnessing the AI for evidence-based policy making for e-governance. This is the data values that we have received for the various function implementation for policy making for harnessing the AI-based policy making in the e-governance. Again, this is a line plot of data values that we have received for the various functions for result analysis while we are making the policy making for harnessing AI-based policy making in the e-governances. So in the conclusion, we have concluded that basically the framework that we have proposed, it combines the power of the AI technology like machine learning, NLP with the transparency and security of smart contracts to facilitate the data-driven decision making in the public sector. And also the integration of smart contracts with the framework ensures the integrity and transparency of policy making process. Not only that, they also enable the automation of the policy execution and enforcement, providing a decentralized and immutable platform for stakeholders to engage and participate in the various government processes. This also emphasizes the importance of data quality, privacy protection, and ethical consideration. The results they have showcased with the improvised decision capabilities, enhanced policy outcomes, and increased stakeholder engagement. So basically, policymakers will be able to leverage the AI-driven analysis to identify the patterns, trends, and emerging issues, leading to more targeted and impactful policy interventions. These are the references that we have considered for formulating this paper. And with this, I will be ending my presentation. Thank you so much.
Can you give any example where this will be helpful?
Mr. Prashant Vats, are you there? Mr. Prashant? Mr. Prashant, now there is a session for question and answer based on your presentation.
No, you are not audible, Prashant.
So, sir, let's move to the next presentation, sir.
Yes, sir.
Yeah, sure.
Okay, sir. I think, sir, there is a problem in sir's network and now we have next presentation. Paper ID is 9418. Author name is Mr. Dharam Raj, and the paper title is Vehicular Ad Hoc Network, a review on application and security.
Madam, hello.
Yes, sir.
The paper is rescheduled 6035, paper ID, last paper ID.
6035.
60 paper ID 6035, presented by Shruti Nair. Design of an efficient deep learning model for analysis of ECG and EEG distribution on kidney, lungs, and liver function.
Okay, sir.
Madam Shruti Nair, are you present? Hello.
Stuti ma'am, are you there?
Ma'am, 9418 is rescheduled.
Yes, sir. 9418 rescheduled.
Okay.
Technical season 3.
Okay, okay. Then next.
Then last presentation is 6035.
Okay, okay.
Dr. Garima, Madam, 6035 is not in our Excel list to give the mark segment to evaluate this paper. So what we have to do for it?
Sir, I'll just sharing you. Within a minute, I'll just sharing with the updated list, sir, please. Okay, sir. Yes, and now our technical session is just over. The technical session first is just over. So on the behalf of the 2023 ICACIS organizing team committee member, I thank the respective session chair, Mr. Sunil Kumar Singh sir and Dr. Sunil Kumar Singh sir and Dr. Arun Kumar sir, for their valuable suggestions and their motivation to the authors. I extend my heartily thanks to the authors for their excellent contribution towards the research. I would like to thank my fellow coordinator to help me proactively for this conference. With the permission of the session chair, I am concluding this session. And all the registered authors and participants, they are fill their Google form, they will get the certificate. So thank you so much to all.
Thank you very much for giving us opportunity to evaluate the presenters.
Thank you, sir.
In fact, listen the presenters, not evaluate. Okay,
Thank
fine.
you.
It was.
Thank you, ma'am.
Thank you so much, sir. Thank you, sir.
Okay,
Thank you.
Okay.
Thank you all the participants for your contribution, and we will be join the session at 1 o'clock for our next today's guest speaker. Thank you so much to all. Kindly join at 1 p.m.